Hello, so here we are looking at GCSE Physics for CCEA 2015 and this is Unit 2. Question 3. Draw a circuit diagram showing the apparatus you would set up to obtain the current voltage characteristic or IV graph for a filament bulb. Use the correct circuit symbols. Okay, so what kind of things are we going to need here? We're going to need some kind of power pack or voltage source. And we're going to need some way of varying the current, so a variable resistor would suit for that. The lamp itself is going to have to be in the circuit, and we're going to need to be able to measure the current in that lamp, so an ammeter. We also need the voltage, and that has to go in parallel with the lamp. And so that's your basic circuit. Ammeter measuring the current, voltmeter measuring the voltage across the lamp, and the variable resistor there to allow us to make changes to those values so that we can take multiple values. And that's it. We now have to give a description of the experiment. Describe in detail how you would carry out the experiment. In your answer, you should explain what is done to obtain a series of measurements of both current and voltage. So a series of measurements of current and voltage. So we need to set up as shown and adjust our variable resistor to give a low current. We record the voltage in the current at that low value, and then we need to explain how to increase the current and voltage using the variable resistor, get more current, and basically then repeat that as we record V and I through the experiment. And so you'll be repeating that process of adjusting the variable resistor and getting more voltage and current values until you've got like a good range of current and voltage values. And then at the end of that, after your table has been completed, you would plot a graph of I versus V. So set up as shown, always do that. If you've drawn a good diagram, you don't have to go through lengthy descriptions of how to set this stuff up. Adjust the variable resistor to give a low current and record the voltage and current. Adjust the variable resistor again to give more current, so increasing the current. Record V and I again, and keep repeating this process until a good range of V and I values are recorded in your table. And remember, the whole point of this experiment is to see the effect of the metallic conductor in the bulb filament getting hot. So if you wanted to say something about the range, then you would take the bulb up to full brightness. Okay, that's it then. So the graph below shows how the resistance of the filament of the lamp changes with temperature. And you can see here we've got a range of temperatures in degrees C and their corresponding lamp filament resistances. And you can see that the filament resistance is increasing, but it's not linear. So now we're asked to use the graph to find the temperature of the filament when the voltage across it is 1.2 volts and the current flowing through it is 0.2 amps. So we have a voltage and a current, but the graph is in resistance, so we need to do Ohm's law to get a resistance, and then we look at that graph. So here's our graph. We need now to do a little calculation so we can have a resistance for this column to then plot onto the graph. So R is going to be V over I, just using Ohm's law. So we divide that voltage by that current, and we get that the resistance of the filament is 6 ohms. Our job now is to go to our graph and plot across at 6 ohms and see what temperature that corresponds to. So we plot across there at 6 ohms, and then we plot down to the temperature axis and put another line in, and then attempt to measure what that temperature there is. Okay. So as you can see, it's coming in at around about 1425 or so. And so we just record that. So just use Ohm's law to get a resistance and then zip that across to the graph value and see what the corresponding temperature is. Part B. The photograph shows a solar panel on the roof of a house. This is made up then of a number of photocells. The photocells produce electricity directly from sunlight. Information is part of the manufacturer's specification for a single photocell, and it says peak voltage 0.75 volts, peak current 420 amps, and area 18 centimeters squared. Each photocell behaves like a tiny battery. In what way would these be connected to produce 240 volts? So we're going to need to put those in series. If they behave like a battery, we can put batteries in series. Cells in series to form a battery. And if you put them in series, you should be able to get a higher voltage. And so that's what's going on here. So we need to see how many of them in this second part would be needed to get 240. So we need to think about how many cells are needed. And if we divide the total voltage needed by the voltage each cell gives, we should be able to figure out how many of them would make 240 volts. So we take 240 and we divide by the 0.75 that each one produces, and that gives us a total number of cells of 320. And so 320 cells, and they all are 18 centimeters squared. Multiply those and we got 5760. In the brightest conditions, each solar panel can produce 100 watts of electrical power. So calculate the area of the roof which must be covered with solar panels to produce a power of 3.2 kilowatts, and give your answer in meters squared. Remember, 1 meter squared is an area of 100 centimeters times 100 centimeters. Okay, so we need 3.2 kilowatts, and we've got 100 watt per panel. So that means we're going to need 32 panels in total. So the total area is going to be our 32 times the area of a panel that we got in the last part, which is 5760 centimeters squared. So we end up with 184320 centimeters squared. And we need to divide that by 10,000, because 100 times 100 is 10,000, in order to convert that into meters squared. Because remember, there's 10,000 centimeters squared in a meter squared, so we get 18.432 meters squared. Okay, so multiply our 32 panels by the area we found in the last part for one panel. That gives us this big value in centimeters squared, and then divide by 10,000, because remember, 100 times 100 is 10,000. So there are 10,000 centimeters squared in a meter squared, and that gives us 18.4 roughly meters squared of roof needed. And that concludes our business with this question.